Okay, so question number 20, page 346 in your Finney text, Calculus Graphical Numerical Algebraic AP Edition textbook. So we want to use the DI method, or the integration by parts method. So we want to say, okay, well, here's the D, here's the I columns. Whoa, that's crooked. And we want to, not much better. We want to figure out, plus, minus, plus, minus. We want to figure out which one we want to use on the D column, which one we use on the I column. So if you go through this list, sometimes this helps. Lie 8. So this is logs, so we don't have any logs there. This is inverse trig, don't have any inverse trig there. Algebraic, and then we don't have any algebraic really. And T is trig, and then E is exponential. So here's the trig, here's the T, and here's the E, right? So as far as the derivative goes, let's put sine of 2x here, and then let's put e to the negative x here. Okay, so let's integrate. If we integrate, derivative of sine is cos, so it's going to be cos 2x, and then times the chain rule says we got to do times 2. Okay, all right. This one here, if we take the integral of e to the x, or e to the negative x, it's e to the negative x, but it's 1 over negative 1, or negative e to the x, right? Okay. So here now, if we go again, because we haven't hit 0, we can't easily integrate a row. There's no repeats. Those are the 3 things you check, right? Do you hit a 0 row? Like, do we have a 0 here somewhere, and then you stop? We don't have that. Is the row easy to integrate by sight or by some other methods, u substitution or whatever? Not really. It's very much the same as the original, so this is not much easier. And are we repeating anything yet? No. Okay, but let's keep going here, right? What's the derivative of cos? Derivative of cos is negative sine. So we've got negative sine of 2x. We've got a 2 there already, and we have to multiply by 2, so this is going to be 4. Nope. Yep, it's going to be 4. Okay. And then the derivative of negative e to the negative x is e to the negative x times negative 1. All right. So this to me looks like sort of type 3 here. I don't know. Did anyone else do it this way? Type 3? Again, I don't have this in front of me here. I'm just helping you out with this question. But type 3, it says that we have a repeating. So if you look at this, this is repeating the first row, isn't it? Okay, that's the same integral as what we started with. So I wonder if we shouldn't stop now and then do that type 3 method. Okay, so let's give it a try. So what does this equal? Well, in order to write our solutions without just writing all integrals, we do want to look at this sort of diagonal piece, right? We want to look at this diagonal piece. So we're going to go negative e to the negative x sine of 2x. That's going to be the first term. And then we're going to go also down the row here like this. So we're going to do this. And then we're going to go, so that's a minus times a plus, so it's minus again. Minus e to the negative x, cos 2x. Okay. And now we use this row. And so remember, each row is an integral. So that's an integral. So now I'm going to write, is that a minus? So it's a plus, a minus here, yeah, plus. So minus now I'm going to bring this 4 out as well. Minus 4 times the integral of sine 2x times e to the negative x dx. Now why is that important? Well, because it's the same as the original integral. Okay, that's the same as the original integral. So let me just pause and rewrite this here in one solid row here. Okay, so yeah, we did miss a 2 in front of the cos there. We got that in there now. I've rewritten this whole row. And when we hit a repeat, and this is from last lesson, guys, right? When you hit a repeat, this here is really a common term to this here, right? So that's great. What we're going to do is we're going to add the opposite. We're going to add 4 of these to both sides, okay? So plus 4, okay? Which is going to, okay, I'll just finish that off here. Sine 2x dx, all right? And what that's going to do is going to give us, and again, remember, we want to find out what this whole thing equals here. So we are close. We just have to divide by 4, divide everything by 4 now. So I'll do this in black now. Here's your answer. So the integral of e to the negative x sine 2x dx, right? Sorry, divide by 5 now because this is 1 plus 4. We got 5 of these. So now this is gone. I have this. Do you want to factor out a negative e to the negative x? I think that would be appropriate. Negative e to the negative x. That's going to be left with, sine x, sine of 2x, minus 2 cos 2x, right? And then, of course, we want to divide by 5 because this was 1 plus 4. There's 5 of these now. 5, I'll write that there, and divide by 5. Divide by 5. Okay, now I'm going to scan everything. We're just going to double check everything here on that. All right, so yeah, other than this this plus sign right here, it looks like that might be the answer. Let's see, what's the class? All right, so plus C. That's the other thing that we're missing there, plus C, of course. So we've got the signs right. I changed that minus to a plus there because we took out a negative. So a negative comes out, or the negative comes out. That's a plus here and a plus there, of course. Plus and plus. And yeah, so that's the answer for number 20. Okay. And that, again, that's your type 3 DI method, type 3. And the 3 types, again, are when you get 0 in the derivative column, you stop, okay? And then you just do your diagonal pieces and you're done. The second one is where you run into a row that's easily integrated just by sight or by use substitution. You can stop and do it there. Or where you have a repeated integral. So one row is a repeat of the original integral, and then you do it this way. So that's type 3.